Good morning, students. Yesterday, you know that from that chapter Thermodynamics, we completed what is called thermochemical equation. After that, example of thermochemical equation and what are the rules to write the thermochemical equation. Today, we want to start another point. We want to study some important definitions from that chapter Thermodynamics, that is standard enthalpy of formation, standard enthalpy of combustion and enthalpy of reaction from enthalpy of formation. First of all, thermodynamics. From this chapter, we want to study the definition. Enthalpy of formation. Enthalpy of formation. It is written, denoted as delta H formations. Here 0. Delta H 0 formation means standard enthalpy of formation. You know that we want to prepare H2O liquid, that is water. You know that formation of water, as you know, water consists of which elements? Hydrogen and oxygen. So, water is formed by the reaction between hydrogen, standard state gas, plus oxygen gas. You know that to balance the reaction, we want to write here 1/2 O2. So, whatever enthalpy change takes place during formation of liquid water, that is called enthalpy of formation, denoted as delta H0 formation. So, standard of enthalpy of formation of water is minus 286 kilojoule. Minus 286 kilojoule. Now, we can define what is called enthalpy of formation. Standard enthalpy of formation of compound. Standard enthalpy of formation of compound. Standard enthalpy of formation of compound. Formation of compound. Formation of compound. Formation of compound is the enthalpy change that accompanies. Is the enthalpy change that accompanies a reaction in which one mole of a substance, 1 mole of pure compound, 1 mole of pure compound is formed from the elements in its standard state, from elements in standard state, from element which are also in their standard state, So, whatever chemical reaction written here, formation of H2O liquid from the elements H2 and O2 to give H2O liquid. What enthalpy change takes place during formation of water? Minus 286 kilojoule. What minus sign indicate? It is released. When 1 mole of hydrogen combined with half mole of oxygen which are in their standard state to form the pure compound which is also in their standard state, that is called as standard enthalpy of formation. So, next point, standard enthalpy of reaction from standard enthalpy of formation. Next point, standard enthalpy of reaction from standard enthalpy of reaction, enthalpy of reaction from standard enthalpy of formation, standard enthalpy of formation, enthalpy of formation. So, standard enthalpy of reaction from standard enthalpy of formation. You know that whenever we want to calculate the standard enthalpy of reaction, there are some important points. For example, you know that calculation of standard enthalpy of reaction from standard enthalpy of formation. Here have some rules. First important one is that standard enthalpy of element, standard enthalpy of element, enthalpy of element in its standard state is 0. For example, standard enthalpy of formation of water is 0. Similarly, that is standard enthalpy of formation of water H2 is equal to 0. Similarly, standard enthalpy of formation of chlorine is also 0. Similarly, standard enthalpy of formation of carbon is 0. So, first important point to know, whenever we are going to calculate standard enthalpy of reaction from standard enthalpy of formation, first important point is that standard enthalpy of element in its standard state is 0. For example, you know that H is called atom of hydrogen, H2 is called molecule. This is the atomic state, this is the molecular state or elemental state. So standard enthalpy of hydrogen is also 0 and hydrogen in its elemental state is also 0. Similarly, chlorine, standard enthalpy of formation of chlorine is 0. Standard enthalpy of carbon in its standard state is also 0. So second important point is that as like this. You know that standard enthalpy of formation of an element is 0, and second important point is standard enthalpy of formation of a compound is equal to its standard enthalpy. Standard enthalpy of formation of compound is equal to its standard enthalpy. Here, consider a general reaction. From this general reaction, it is clear that, for example, you know that A plus B react to give A plus B react to give C plus D. This is the general chemical reaction. Small a, coefficient of reactant A, small b, coefficient of reactant. Small a is the coefficient of reactant A, small b is the coefficient of reactant B, small c is the coefficient of product C, and small d is the coefficient of product D. Now, standard enthalpy of reaction is given by delta H0 formation is equal to that is standard enthalpy of product, that is standard enthalpy of product C plus standard enthalpy of product D minus standard enthalpy of reactant A plus standard enthalpy of reactant B. So here that is equal to standard enthalpy of standard enthalpy of formation of standard enthalpy of formation of carbon, standard enthalpy of formation of carbon plus standard enthalpy of formation of product D, standard enthalpy of formation of product C plus standard enthalpy of formation of product D minus standard enthalpy of formation of reactant A plus standard enthalpy of formation of reactant B. So from this equation we can write this equation. Now here we can write that is equal to summation of standard enthalpy of formation of product minus standard enthalpy of formation of a reactant. So here we want to study one example for this. The example is as like this. You know that calculate the standard enthalpy of reaction by using this formula. We want to calculate the standard enthalpy of the reaction. So reaction is as like this. You know that C2H6, that is the molecular formula of ethane. The standard state of ethane is gas. You know that when it reacts with oxygen gas, this reaction is called as combustion reaction. You know that reaction with oxygen is called combustion reaction. Here, whenever there are carbon, hydrogen and oxygen in the reactant, products are generally carbon dioxide gas and liquid water. So here CO2 gas plus H2O liquid. You know that this reaction is not balanced. We want to balance this reaction. Here 2 CO2, here that is 2 H2O, that is 2, here we can write as like this to balance the reaction. 2 C2H6 plus 7O2, it gives 4 CO2, and here that is oxygen 6H2O. Now we want to calculate the standard enthalpy of reaction from standard enthalpy of formation. Just now we studied standard enthalpy of formation is equal to standard enthalpy of formation of, here some data is given. Standard enthalpy of formation of CO2 is equal to minus 393 kilojoule, and standard enthalpy of formation of water is given kilojoule per mole. Standard enthalpy of formation of water is equal to minus 285.6 kilojoule, minus 286.6 kilojoule per mole, and standard enthalpy of formation of ethane is here minus 286.8. Okay, standard enthalpy of formation of ethane C2H6 is equal to -84.9 kilojoule per mole. You know the formula, that is standard enthalpy of reaction. Standard enthalpy of reaction is equal to, just now we completed the formula, standard enthalpy of formation, summation of standard enthalpy of formation of product, summation of standard enthalpy of formation of product minus summation of standard enthalpy of formation of reactant. So you know that when we put the values of all these, that is CO2, as you know that there are 4 CO2, that's why we want to multiply this value by 4. For water it is 6H2, that's why we want to multiply by 6. And here C2H6 is multiplied by 2 because there are 2 molecules of ethane. Here you know that standard enthalpy of element in free state is 0. That's why here the value of standard enthalpy of formation O2 is 0. And when you put the values of all these in this equation, we get the final answer -3119 kilojoule. Standard enthalpy of reaction is equal to, that is -3119 kilojoule. So that is the final answer of this example. Okay, now the next point, standard enthalpy of combustion. After this example, we want to study the next definition, standard enthalpy of combustion. The next definition we want to know, that is standard enthalpy of combustion. Standard enthalpy of combustion denoted as delta H0 in standard state or combustion C. So standard enthalpy of combustion, what is called standard enthalpy of combustion? You know that C2H2, that is the molecular formula of acetylene, and you know that acetylene is a gas. When C2H2 react with oxygen, it is also gas, and the state of oxygen is gas. So acetylene when combined with oxygen, this reaction is called combustion reaction. Why this reaction is called combustion reaction? Because acetylene reacts with oxygen. Reaction with oxygen is called combustion reaction. You know that what elements are there in the reactants? Carbon, hydrogen and oxygen. What are the products of this reaction? The products of this reaction is carbon dioxide gas plus H2O liquid. You know that we want to balance this reaction, and there are 2 carbon. Here we can balance carbon by writing 2. Now number of oxygens, here 5. So we want to write here, to balance the oxygen, 5 by 2. Means 2 get cancelled, that is 5 oxygen. Here there are 5 oxygen. So all the elements in the reactant and products are balanced. You know that the standard enthalpy of combustion for this reaction is -1300 kilojoule. Standard enthalpy of combustion is equal to -1300 kilojoule. So here what is called combustion? The reaction of compound with oxygen is called combustion. You know that acetylene C2H2 gas when react with oxygen, this reaction is called combustion reaction. What are the products of combustion reaction? Carbon dioxide gas and H2O. How much heat is released? 1300 kilojoule of heat is released. That's why this reaction Generally, combustion reactions are exothermic reactions. It is evolved. So we can write the definition of combustion as like this. The standard enthalpy change accompanying a reaction. Standard enthalpy change. Standard enthalpy change. Enthalpy change accompanying standard enthalpy change accompanying a reaction in which one mole of the substance in its standard state is completely oxidized. In its standard state is completely oxidized. You know that here acetylene react with oxygen, that means acetylene is oxidized. This reaction is also called as combustion reaction. So standard enthalpy change accompanying a reaction in which 1 mole of a substance, that is 1 mole of acetylene here, standard state gas, in its standard state is completely oxidized. That is called as enthalpy of combustion. Now the next point of this chapter, thermodynamics, that is bond enthalpy. Okay, next point, this chapter thermodynamics, that is bond enthalpy. What is called bond enthalpy? Bond enthalpy. You know that here hydrogen diatomic, it is gas, it is its standard state. You know that one molecule of hydrogen consists of 2 atoms of hydrogen. There is a covalent bond between 2 hydrogen atoms in this CH2. You know that when this hydrogen bond is broken between hydrogen molecule, 2 atoms of hydrogen gas are formed. So, what amount of heat is required? That is 436.4 kilojoule. That means standard enthalpy change for this reaction. Which reaction? The reaction in which the bond breaking takes place between hydrogen molecule to form 2 atoms of hydrogen gas. How much heat is required? 436.4 kilojoule of heat is required. So this is called as bond enthalpy. Or we can write enthalpy change required to break a particular covalent bond. Enthalpy change required to break a particular covalent bond, in 1 mole of gaseous molecule to produce in 1 mole of gaseous molecule to produce atoms called bond enthalpy. So you know that This is the 1 mole of hydrogen gas. These atoms are separated from that hydrogen gas when a covalent bond is breaking of covalent bond is between these hydrogen atoms takes place, or covalent bonding molecule of hydrogen takes place. That means what is called bond enthalpy? Enthalpy change required to break a particular covalent bond in 1 mole of gaseous molecule to produce atoms called bond enthalpy. So to break this covalent bond between hydrogen atoms, how much heat is required? 436.4 kilojoule of heat is required. That is called as bond enthalpy. That is called as bond enthalpy. Now, next point, average bond enthalpy. Okay, next point, average bond enthalpy. Next point, average bond enthalpy. Average bond enthalpy. You know that here H2O gaseous. You know that there are 2 oxygen hydrogen bonds in H2O. So what we get after breaking the bond between these 2 bonds? We get that is 2H gaseous plus 2 hydrogen atom gaseous plus oxygen gaseous. The standard enthalpy change for this reaction is 927 kilojoule. Is 927 kilojoule. We are going to study what is called average bond enthalpy. You know that there are 2 bonds between 2 oxygen hydrogen bond between this water molecule H2O, which is in gaseous state. So enthalpy required to break this first bond and to break this second bond is different. That's why in this case average bond enthalpy is taken. For example, you know that we can write this same reaction in the 2 step as like this. H2O gaseous, first bond breaking takes place, OH gaseous plus H gaseous. You know that OH gaseous, it gives H gaseous plus O gaseous. You know that OH gases get cancelled. Here H2O gaseous, it gives 2H gaseous plus oxygen gaseous. So standard enthalpy of the first reaction is, that is 499 kilojoule. 499 kilojoule. And for second reaction it is 428 kilojoule. 428 kilojoule. So to break the first bond between this oxygen and hydrogen, how much energy heat is required? 499 kilojoule. And to break the second bond, 428. These 2 values are different. You know that the sum of these 2 values, it becomes 927 kilojoule. 927 kilojoule means again we get this reaction. So in this case, you know that 927 divided by 2, that is equal to 463.5 kilojoule, and this 463.5 kilojoule is called average. So 927 divided by 2, you know that once again the average bond enthalpy for this, we written this reaction, and you know that this reaction is written in 2 steps. The enthalpy change for the first reaction is different, second reaction is different. So what is called average bond enthalpy? That is to break the two bonds, we divide 927 by 2, that is equal to 463.5 kilojoule. This is called as average bond enthalpy. Now the last point we want to complete, that is reaction and bond enthalpies. Last point, reaction and bond enthalpies. Reaction and bond enthalpies. Reaction and bond enthalpies. Reaction and bond enthalpies. You know that in a chemical reaction, bonds are broken and new bonds are formed. For example, H2 gas plus I2 gas, it gives 2HI gaseous. You know that H2 and I2 is called reactants, HI, hydrogen iodide, is called product. What happens? That is, bond between hydrogen iodine is broken and new bond between these hydrogen iodide are formed. That means in a chemical reaction, bonds are broken and new bonds are formed. So here the enthalpy for this reaction, the enthalpy of this reaction can be find out as like this. That is delta H reaction, that is standard enthalpy change of reaction, is equal to summation of standard enthalpies of reactant, summation of standard enthalpies of reactant minus standard enthalpies of products, minus summation of standard enthalpies of product. Reactant minus product. So that is called as reaction and bond enthalpy. So we can find out the enthalpy of the reaction from bond enthalpies. Means enthalpy of the reaction is found out from the bond enthalpies. For this, one example is given, that is N2H4. You know that N2H4, that is molecular formula of hydrazine, plus that is H2 gas. It gives 2NH3 gaseous. You know that here, whenever the standard enthalpy of nitrogen-hydrogen bond is given, hydrogen-hydrogen bond is given, and that is nitrogen-nitrogen bond is given, we can find out the enthalpy change of this reaction from this bond enthalpies. So here, standard enthalpy of nitrogen-hydrogen bond is given, that is 389 kilojoule per mole. 389 kilojoule per mole. For standard enthalpy of hydrogen-hydrogen bond is given, that is 435 kilojoule per mole. 435 kilojoule per mole. And standard enthalpy of nitrogen-nitrogen bond is given, that is 159 kilojoule per mole. 159 kilojoule per mole. So when we put the values, you know that here in this reactant there are how many nitrogen-hydrogen bonds? 1, 2, 3, 4 nitrogen-hydrogen bond, 1 nitrogen-nitrogen bond. Similarly, in this reactant one hydrogen bond is there, and you know that in NH3 there are 3 hydrogen bonds, but there are 2 NH3. So when we put the values of all in this equation, finally we get the standard enthalpy of reaction, that is equal to minus 184 kilojoule, minus 184 kilojoule. So very simple example is there to know what is called reaction and bond enthalpy, or how will we find enthalpy of the reaction from bond enthalpies. For this, it is a typical and very easy example. Okay, we will stop here. Thank you.